I will start from the beginning. Okay. So what we are dealing with is variable. We have to put variable dimensions and positions to our geometry, right? So first we will start with uh, core, right? So which of this drawing is core? Rectangular one is our core. So just maximize this. You will get create a rectangle. Double click on that. This window will get popped up. Then now you have to assign variable dimensions. So give some variable to the x size and y size. So we will assign variable as WC for width of the core. So when you will click on other window, this small window will get popped up. Why? Because when you are assigning variable to something, you have to give its initial value. It's compulsion to give its initial value. So for width of the core, it is of length type, right? So in unit type, we will select length. It is having multiple options, but because we are dealing with length, we are selecting length here, right? Second is unit. In which unit you want. So again, we have multiple options. We are selecting here, and then value, what value you want to give, what initial value you want to give. So for now, I'm just keeping it at 24. Okay, you understand this?
Yes, ma'am.
Yeah. Then second is height of core, right? So I'll just replace this with HC. Again, HC, when you will click on it, this window will get popped up. So again, HC, unit type is length, unit is and the value I have kept 24, right? Here, now the positions are depending on the dimensions, right? Right? Correct? You guys understood this? Based on your dimensions, you are assigning the positions, right? Is it clear?
Yes, ma'am.
Yeah. So
Yes, ma'am.
what will be the position in terms of variable? Can any one of you tell me this? What should I write here? Before it was WC, it was 24, so we have written minus 12. So now what will come here?
WC
Will
by
it?
2.
Yes, WC by 2, right? Similarly, what will come here? HC by 2, right? Because we want our geometry to be centralized, we are keeping our dimension in, we are keeping the position in such a way that it should be in the center, right? So yesterday we learned how to position this, right? We said that if x size is if x size was 24, we need minus 12, which is WC by 2, right?
Yeah.
Yeah. So that's why we have kept position as WC by 2 here. Because now we want to make everything in terms of variable. Because when you will change your WC from 24 to 36, its position should not be 12 only, right? It should change according to that to make your geometry centralized. You are understanding this?
Yes, ma'am.
Okay. So this you understood, right? How we are assigning variable to our variable to the dimension of core. You guys understand this, right? Okay, so let's just now what is the next thing? So we are done with the core. Now we will deal with window, right? Which is our window? This two rectangles were our window. Rectangle 2 is our window, right? This. So this is the dimension that we allotted yesterday. Here in excess, what should I write? As variable, it will be WW, right? And in Y size, I'll write HW as my variable. Okay. Hello. Are you guys understanding it, or should I just repeat it again?
Yes, ma'am.
No,
You
ma'am,
are
understand.
understanding? Yeah.
Ma'am,
Good.
can you repeat once again, ma'am?
Yeah. Uh, so let's see from here. Now we are in yesterday's class, we learned how to draw this geometry with fixed dimensions, right? Today, we we don't want to keep this dimension as fixed. We want to keep it variable. So what we did yesterday in the same order we are following today, but instead of giving fixed dimensions, we are replacing it with variable. Okay? Is it clear to you? So yesterday, what we did, we started by drawing this big rectangle first, right? So there we have assigned this as 24 because it was 24 for the previous
Okay, ma'am.
experiment, and here it was
Yes, ma'am.
24. But today we are replacing it that 24
Yes, ma'am.
with our variable WC and HC. What was our next step? To draw this windows, right?
Okay, ma'am.
So there
Yes,
we
ma'am.
have given dimension of 6 into 8 for that window. So today we are just doing the same thing but replacing the fixed dimension by variables. And what is its importance, you will understand in the later stage also. But for now, I'm just telling you that if you want to change something, you don't have to change your position is depending on your dimension. So if you change your dimension to 24, now 24 to 36, then again you have to change the positions and all, right? So we are just making it dependent. So by changing one variable only, it will automatically get adjusted. Right? Understood?
Yes, ma'am.
Okay. So yeah, we are just keeping it same at 6 mm only. Uh, you do one thing. I am replacing it in the same geometry. You don't like for now you do this, but it's as a home assignment, I'll recommend you to draw different geometry with variable dimensions. Okay.
Okay, ma'am.
For now, just replace it here only because we don't have that much time. But after this class, please draw your own geometry with variable dimensions. Right? Then you will understand it better. So here we are replacing it with HW. Same length base unit is mm, value 16. Initial value you have to give. Like it is compulsory to give initial value. Okay. Now just tell me how to position how we will decide the position. Yesterday, what we did, do you guys remember? For taking out this position, what we did?
We divided, ma'am, actually. We divided x-axis and y-axis by 2.
Yes, so let's do that. Okay.
Ma'am, your screen is not visible, ma'am.
Yes, I've stopped sharing. Just wait.
Okay,
And
ma'am.
yeah, just wait. So yesterday what we did is for finding uh, its position, y-axis position was HW by 2, right? My screen is visible?
No, ma'am.
No? Okay. Let me try again. Yes. Y-axis position was directly HW by 2. What we did to find x-axis position? Does any one of you remember? And can you tell me in terms of variable? How we got this -8?
Actually, it is in negative side, so we got minus, ma'am.
No. Why this 8 value has come? Let's not talk about sign. Why that 8 value came?
Actually, it is off of 16, no, ma'am.
Considering the origin value.
From origin,
Yes, ma'am.
this value was 4. How we got this 4?
2 plus 2, 2 by divided into two sections. 2 plus 4.
What? You don't remember, right? Okay, it's fine.
Window
It's
was
fine.
4
Ma'am,
mm away from
ma'am,
4, ma'am.
by dividing 12, three equal parts, we get 4, ma'am.
For yes, plus minus 2 times WW, right?
Yes.
My screen is visible to you, right?
Yes, ma'am.
So WC minus 2 times WW. Here what we got is 12, right? 6 plus 6, 12. 24 minus 12 was 12. So here we got some value, right? We divide this by 3. This way we got this value. Understood?
Yes, ma'am.
So now today what we will do is 2 times WW by 3. Then what we here we will get this value, right? Now again we have to divide it by 2 because we want this. Oh, sorry. Because we want this value, right?
Yes,
Are you guys understanding? So again, if we
yes,
will
ma'am.
divide by 2, it will become 6. So it will be WC minus 2 times WW upon 6. So we got this value now. Okay. Plus WW is how we have achieved R minus 8. Yesterday we did like this, right? Do you guys remember this?
Yes, ma'am.
This was our point, right? Where from the this was our point from where we start. Okay, let me just. Um, huh. My screen is visible.
Yes, ma'am.
Okay. So this was our point from where we started drawing our window, right? So it was this width means this width plus this width, right? How we got this width as 2 mm, that we just discussed. And this is plus WW, that is 6. That's why we are getting minus 8, right?
Yes,
Right?
ma'am.
Yeah.
Yes, ma'am. Right.
Yes. So we have to write this formula there where we got for y-axis it was straightforward. What is the variable? HW by 2, right? It was straight for y-axis. It was straightforward minus HW by 2, right? But for x-axis, what we did yesterday was you would have changed the origin point. Sorry. You can start drawing from this point also. So it will be just minus 2. But because yesterday we started drawing from this point, we have to see what is the position of that point, right? So origin point should be considered while we give the positions, right? So if this was the initial point, it would have been just minus 2. But because this is our origin point, uh, we got minus 8. And how we got, I just told you. You guys understood this, or should I just repeat it again?
Yes, ma'am. We understood it.
Okay, are understanding, right?
Yes, ma'am.
Yeah. So if you don't want to do that much calculation, it's fine. You can change your origin point and just get away with it. Okay. So it is WC minus 2 times WW by 6, put it in bracket, plus WW, right? Let me replace this error because we have not replaced it. I forgot to replace it first. This variable are unknown for Ansys. That's why it is throwing that error. WW and this one is HW, right? This is HW by 2. And how we have calculated this? HC, WC minus 2 times 2 into W upon 6. You got it? You got this? Are you guys confused? Hello?
Doing, ma'am. No, ma'am. Actually, doing.
Okay, you guys are doing it. Yeah. Is there anyone who has not understood this or is confused? Please let me know. I'll repeat it again. It's fine.
Yes, ma'am. Please repeat it again, ma'am.
Yeah. Yesterday you understood how we have given positions for this?
Yes,
Uh,
ma'am.
Yesterday you understood, right? How that minus 8 came.
Yes, ma'am.
Yes. Today we are doing the same thing, just instead of values, we are replacing it with variables. That is the only thing we are doing here. So yesterday, when we calculated this -8, we have done some um, like some mathematical calculations, and we got this -8, right? This was that mathematical calculation. This was that mathematical calculation that we did yesterday. It's just that instead of numbers, we are using variables here. So when okay, when we said that this is 4 mm, we have done some calculations, right, to calculate this as 4 mm. Hello, hello, am I
Yes,
audible?
ma'am.
Yes.
Yes, ma'am.
So
You are on.
the same calculation we are doing here, but instead of number, we are just replacing it with these variables. So yesterday, for calculating this 4 value, what we did is HC, here now I have replaced it with WC. Okay. So it was WC minus 2 times this WW value, means this one, this first W, and this one is second WW. Okay. So 2 times WW by 3. Why we did by 3? Because we have three spaces left, like 3 dimensions that we need to calculate. That's why we have divided this by 3. Understood? So this is how we got this 4 mm, right? Right?
Yes, ma'am.
So when we did by 2, we got this point, right? Like this is 2 mm, and position you have to calculate with respect to origin, with respect to center, right? So this from center, this space is 2 mm, right? So that we got by dividing this to 2. That's why we again divided by 2. So this will come as WC minus 2 times WW by 6, which is what we have written here, right? This part you understood?
Yes, ma'am.
Yeah. Now the other thing is our when we started drawing our rectangle. Okay. When we started drawing our rectangle, we started from here, not from this point, right? So again, we have to add this WW there to get position of this point, right? So that's why we have added here like plus WW. Now you got it, how we got the position. If you would have started from this point, drawing your rectangle from this point, it would just have been this much, right? But because you started from this point, you have to add this length also. Understood? Or it's still confusing? I think now it's clear for you guys, right? Should we proceed?
Yes.
Yes.
Yes, ma'am.
Yeah. So because we have duplicated this window, so we don't need to adjust for this because it's already duplicated, right? So we will not do anything for that. Then what we did next, we started with our windings, right? So anyone, if I replace my X size with WWN and my Y size with HWN, can you guys tell me in terms of variable what is the position? Like yesterday only, and this is that point, this point is that. Can you guys tell me? For this, we need another variable, like, right? WNG, which is the gap between the windings, right?
Yes, ma'am.
Yes. For this, we need another variable, gap between the windings. So let's you can define it here also, it's fine. It will just ask its value and then we can assign it. So now, can any one of you tell me the position with in terms of variable, like how we got this -3 and 7.5 yesterday? Just calculate it on your books and just tell me. Think about it and tell me properly. It's very hello.
Yes, ma'am.
Yeah. So just
WC minus 2 WW by 6 plus 1, I think so. Ma'am.
+1. How that +1 came? It will not be
Actually,
+1. It will be terms of variable only.
okay, ma'am.
This +1 came because this is WNG. That variable we have not defined. Plus this WWN, right?
Yes, ma'am.
Because we are calling this width as WWN and this space as WNG. So yesterday we added this, right? This 0.5
Yes,
and
ma'am.
this 0.5. That is how we got 1. So we have to replace that 1 also with variable.
Uh, 2 times of WW and we can replace, ma'am.
But it's not compulsory that WWN will be same as WNG. The WNG is spacing between the turns, this spacing between the layers, this, and WWN is the width of winding. In our case, it is same, but it's not compulsory that it will always be same, right?
Yes, ma'am.
That's why we will not assign, like we will not just say directly it will be +2 times WWN. We will say that it is this WNG, which is spacing between the turns plus width of the winding, WWN. Understand?
Okay, ma'am. Yes, ma'am.
So let's go again. You guys understand how we calculated this, right? This 2, how we got? By this formula, right? So now we want this point. First, we wanted this point. So what we do, we have added this WW. But now we want this point. So what we will add? This WNG plus this WWN, right? Are you guys understanding or it's confusing? Please tell me. Like I'll
Yes,
try to
yes, ma'am.
explain in some other way then. Is it confusing
No,
or you
ma'am.
are being able to understand? Oh, just thank you. So this is WNG and this is WWN, width of winding, and this is gap between the winding. So instead of now WW, we will just write here WNG plus WWN, right? You understood how we are
Yes, ma'am.
assigning the position with respect to variables? Okay. So, okay, that's what it was before. I, I don't want to write it again. So what I'll do is I'll just copy it from here and just replace it. Till this point, it was same. Now here it WWN plus WNG, right? Till this, it was same. How we got that 2 mm. Now this is winding width we have to add and gap between the winding we have to add, right? And what is the position for winding height? Like what will be the position with respect to winding height?
HWN by 2, ma'am.
Good. It's like yesterday what we did, it is same like that, just we are replacing it with variables now. Okay.
Yeah, ma'am.
Yeah, because we have not defined WNG before, that's why it is asking. So WNG, it is length type, right? Mm, and what is its value? 0.5. Initial value we are keeping 0.5. You understood? Is it clear?
Yes. Yes, ma'am. It is clear.
Yeah. So similarly, so this one is done, right? Now what we can do is we should have just duplicated this. It would have acted the same because we have copied it and moved. I think we will face that issue. Okay. It's fine. Just what we have done here, just copy it and paste it in all the triangles. Okay. Because yesterday we have not duplicated it. We have copied and pasted, right? So in copy and paste, the dimension will not change just like the other one. In duplicated, it will change, but in copy and paste, it will not change, right? That's why here we have to replace it with the variable, with the first variable. Understood the difference between copy and paste and duplicate? Okay. What we will do is we'll just copy it from here and paste it. guys are understanding now what I'm doing? Hello?
Yes, ma'am.
Yeah. This is duplication. So on right hand side, you don't need to change anything. Because yesterday when we have drawn the first winding, we have just copy pasted the other four. That's why we are changing its time, like which variable only. Okay? Let me, it's window, no? Previous sector. Fine. Yes. I was doing just that. Okay.
Hello, ma'am.
Yes.
Can you explain what is WC and WW?
I started with that only, but okay, I'll again explain what is WC and WW. Okay. Uh, Yesterday you were present. Hello. Yesterday you attended the class.
Yes, ma'am.
Yeah. So you remember how we have drawn this rectangle?
Yes, ma'am.
While drawing this rectangle, we have given this fixed dimension, right?
Yes, ma'am.
Now, see, in mathematics, if you want to find something, you replace it with some variable. Let's say if you want to find cost of something, so you say let the cost of this item be X, right? You assign some variable to that, right? It is similar
Yes,
here.
ma'am.
Uh, I don't know what is my WW for now. Let's assume I don't know my WW. Okay. So sorry, I
Okay.
don't know my window height, core height. So I'll replace it with some variable which I'm calling it as HC, core height. Okay.
Okay,
But
ma'am.
while uh, giving this variable, you have to give its initial value. So you can give any initial value because I know this, like this is 24. That's why I've just assigned it 24. But you can give any initial value you want. You can change it at any point you want. Okay.
Okay,
So
ma'am.
this HC is the variable for height of the core. Okay. Similarly,
Okay, ma'am.
this WC is the variable for width of the core. Yesterday we have
Okay, ma'am.
given the fixed value. Today we are not giving fixed value. We are replacing it with variables. This is the only thing we are doing. Its importance you will realize in later sessions, but for now just like understood why we are doing this and what we are doing. Okay. Similarly, this 6 we are replacing it with variable which we are calling it as WW, right? Width of window. Okay.
Okay, ma'am.
And this with HW, height of window. Okay.
Okay, ma'am.
Similarly, we are replacing this 0.5 with a variable which we are calling it as WWN, width of winding. Okay. And
Okay,
this
ma'am.
0.5 we are replacing it with WWNG. It is gap between the winding. I think it's WNG or WWG, something like that, right? And this, we are replacing it as HWN, which is height of winding. Now you understood what is this WW, what is this HW and all?
Yes, ma'am.
So like in mathematics, you take that variable as reference and calculate the values of other parameters. Similarly, in terms of variables, similarly, we are doing this for calculating this space, right?
Yes, ma'am.
And this space, then in terms of this space, we are calculating what is the position of windings, what is the position of this window. So it is like that. It is just simple mathematics what we are doing. Okay,
Okay, ma'am.
understood now? I think now it is
Yes,
it
ma'am.
is clear for everyone, right? So now it is clear, right? Okay. So
Ma'am, one more doubt.
yes, yes.
Ma'am, if these windings are kept as a unit, the function formula will be same for all, no, ma'am?
Uh, no, if you will unite them, it can be moved like together. But you have to change the formula.
Okay, ma'am.
Actually, yesterday what like it's not a mistake, it was just to taught you how to use the above function. So what I did is I if I would have just duplicated this winding, what I did yesterday was copy and paste, right? If you guys remember, what we did is copy, paste, and move, right? If you just
Yes, ma'am.
Yes, ma'am.
duplicated it, so you don't need to change that for every winding. Because in copy, in duplicated, it's like whatever happened to this winding will same will happen to that other winding also. But in copy and paste, it is not the case. It is just for your convenience. So it is like a one-time thing. For now, it will look the same. But if you will change the parameters of the original winding, the copied parameters will not change. Understood? Difference between copy and paste and duplicate.
Yes.
Yes, ma'am.
Yes, ma'am.
We duplicated it on the right hand side. Let me zoom it out. I missed it, guys. Okay. So this winding we have duplicated on this side. So we don't need to change parameters for these five because it is just duplication of this. But for this four, because it was copy paste, we have to change its parameters. Understood?
Yes, ma'am.
Good.
Okay.
So now it is clear for you, right?
Yes, ma'am.
Yeah. So yesterday when we copy and paste it, we move this coil, right? That move is also this. This is the first. Oh, sorry. This is the first winding. This is the second winding. No, second winding is this 6, right? Okay. Let me delete this winding and we will copy paste it again. Now I'll see. Just we will copy, we will paste, and then we will move this. right? How we have moved this? Because we want this point to shift here. So we moved it by WNG plus WWN, right? This is how this -1 came yesterday.
Yes.
So what this -1 we will replace by WWN plus WNG. Understood?
Yes, ma'am.
Duplicate. Understood? Now
Yes, ma'am.
let's so if you guys have understood, tell me what will come here. The first move and the second move. Of this is this winding. Tell me. What will come in the first move and what will second move? Any one of you. Okay. You guys still don't get it, right? Or you don't want to speak. What is the issue? You guys understood why these two moves are coming? Yes or no? Just give me a simple answer. Any one of this. Hello? Am I audible to you? Are you
Yes,
guys
ma'am.
sleeping?
Yes,
Okay.
ma'am.
Yeah. Okay. So can you tell me how these two moves had came?
Uh, one we copy pasted, ma'am, one move, and then we
Hmm.
moved
We
rectangle.
again copy pasted that winding. That's why the second move came. And again moved it, right?
Yes, ma'am.
So I'll explain you this very it on basic level. Yesterday, what I did was I draw this winding first, right? Copy pasted this winding, right? And have moved it here, right? Right?
Yes, ma'am. Ma'am.
So this is now my second winding. Now what I have done is I have now copy pasted this winding and then move it here, right? So this is my first move and this is my second move. That's why these two move commands are coming, right?
Yes, ma'am.
But if I would have copy pasted this winding only 4 times, only one move command would have come, right?
Yes, ma'am.
Because I have copy pasted it and moved the first winding and then copy pasted that winding. That's why this move command is increasing, right? You guys
Yes,
got it?
yes, ma'am. Got it, ma'am.
Got it, right? So if you got this, so what will come here? Can you tell me now? For first move command, what is it? WWN plus WNG, right? Is it confusing? Should I explain it on iPad or it's fine? You guys are understanding it. Please respond.
Ma'am, is it okay, ma'am? Understanding.
What will come in the second move then? Same WWN plus
Yeah. And
WNG.
WWN. Yes, ma'am.
Now tell me, if I would have copy pasted this winding 4 times in first move, in for first move, what would have come for this winding? If I would have copy pasted this winding 4 times and have moved it to these places, what would have been the value of first move? Tell me now. Your y coordinates are not changing, right? Just your x coordinates are changing. Tell me. Come on, guys.
Yes, ma'am. WW, 2WWN, 3WW,
Yeah,
like that, ma'am.
WWN plus WNG. For this, it would have been 2 into WWN plus WNG.
2WWN plus, yes.
Right. For this, it would have been 3 WWN plus WNG. And for this, it would have been 4 WWN plus WNG, right? So guys are understanding this? Who has answered this? Can you please tell me your name?
Akash, ma'am.
Good, Akash. I think you have understand it properly.
Thank you.
So we have replaced this for this. This is which winding? 10, 8, right? Similarly, we'll replace all moves here.
Ma'am, I
Yeah.
have one doubt, ma'am.
Yes, ask, please ask.
Ma'am, by construction of a winding, at
Mhm.
a time I constructed 4 windings, ma'am. A pop-up window came into my desktop.
Hmm.
At a time, five windings I constructed, ma'am.
Hmm.
And by creating a rectangle and giving the dimensions of that winding.
Hmm.
At a time, the formula will be given, no, ma'am. That formula comes for all these windings, no, ma'am.
Individual only you have to set.
Oh,
At the
why,
time,
ma'am?
how if you duplicate it if you duplicate this, then only one time you have to write. But if you draw this 4 rectangle in this form, like individually, if you will draw this 5 rectangle without using copy paste or duplicate, then also you have to write individual formula for all 5. Am I
okay,
understanding
ma'am.
it correctly? What you are trying
Yes,
to say? Yes, right.
yes, ma'am. Yes.
Then you have to write individual formula for every winding. You are not. What I'm assuming is you are not using any move command or any duplicate command. You are individually drawing every winding, right?
No, ma'am. No.
Then
Uh, I constructed one winding, ma'am. First winding.
yes, right.
And I mirroring, no, ma'am. Less mirroring.
Duplicating it,
That,
right?
yes,
Then
yes,
you
ma'am.
don't have to set.
I directly constructed then one pop-up window came, ma'am. I rated 5 windings. That 5 windings will be constructed at once, ma'am. At
Right,
only one
right.
time.
That
Sorry,
also
ma'am.
you can do. Right. Then you don't have to. Then if you are just duplicating it, then you don't have to do it for all others. It will perform same like the first winding.
Oh, okay, ma'am.
Okay.
Yes, ma'am.
Yeah. If you are duplicating it, then it's fine. But if you are drawing individual, then you have to give individually. Right?
Yes, ma'am.
Okay. Done. Done with this. Just finish this, okay? Done. It's fine then. Simple ways to copy paste things. Sorry, because it's taking some time, okay? I think we are finished. So now, when you will click on Maxwell 2D design, you can see your parameters here in properties. Are you being able to see it? We are finished with our drawing, right? We are finished giving variables to our design, right?
Yes, ma'am.
Yeah. So when you will click on Maxwell 2D design, are you being able to see your variables here? WC, HC, WW, HW, right? Now
Yes,
you
ma'am.
don't have to go to geometry means here and change it. You can just directly change it from here. See how convenient it has become. So like let's change our winding width to 0.25. See, it is getting adjusted on its own, right? Now you want to increase the spacing. Let's say point from 0.5 to point, just we can write it 1 also. Okay. Right? It has become very convenient now, right? You are directly changing here and your geometry is getting adjusted accordingly. You can, when you will write 36, just, and here 36. By default, it is getting positioned, right? You don't have to do anything. Understood the importance of using variables? How convenient your geometry has become now?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Oh, let's change it. We have changed it to its initial values. Okay. So we are done with day 1 objective and we are done with our uh, day 2 objective, right? Transformer geometry creation with
Yes,
variable
ma'am.
dimension. You guys have any doubt in this too?
Ma'am, in desktop site, that 2D Maxwell, I can't see, ma'am.
Sir? This?
That project manager box, ma'am.
This?
beside
Just
the model one.
maximize this. Just maximize this. You might be seeing this like this, right? Click on this plus. Open this. You'll
No,
see it. Hello?
no,
I think you have yesterday you have not this you are getting this thing. Hello?
yes, ma'am. Yes, ma'am. That ribbon box, all getting, ma'am. And this model and sheets, rectangles, that all getting, ma'am. But
You are
beside
getting
of this
this
box,
3D components model and all.
no, 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 ma'am, no, ma'am,
Are you getting this window like this?
no, ma'am.
Then where is your project? Where you are being able to see the name of your project? Huh? Maybe from view you can just click on project manager.
Okay, okay, ma'am.
From view, click on project manager. Okay,
Yes, yes, ma'am. Yes,
now
ma'am.
you got it. If you are not being able to see this
Yes, ma'am.
properties from view, click on the properties. From where you will able to see your variables. So whatever you are not being able to see, just click from go to view and click whatever you want. Okay, understood?
Okay. Yeah,
So like what day one and day two objectives were we have completed, right? So do you guys have any doubt in this?
no, ma'am.
So should we proceed with our day three objective?
Yes, ma'am.
Okay. So day three objective is how to simulate this thing. So like before moving to day three objective, let me tell you some interesting things here. First is we can assign material to this geometry. So what is this core made up of? Like in real life, transformer cores, what is it made up of?
Iron core.
What?
I think so. Iron core, ma'am.
Yeah, CRGO iron, right? Right? So the
Yes,
materials
ma'am.
Yes,
having flux should flow through this material. What that material has? There's no working of you guys know working of transformer?
Copper, ma'am.
Copper winding is made of copper. I'm not talking about core, where your windings are wounded, where your flux is flowing. Um, so what you will do today is go and read basic principle of transformer. What is this materials are made up of and why? Okay, you guys will do this, right?
okay, ma'am.
Basic working of transformer. What is this core and what is this winding materials? And about losses in transformer. These four things, because I'll tell you this is happening, this is happening, but you should understand why it is happening and why we are choosing a particular material for that. Okay?
Yes, ma'am.
Okay, ma'am.
Okay. Right? So one Yeah, for the windings are made of copper. This everyone knows, right? So
Yes, ma'am.
let's assign. So when you will select your windings and will double click on it, this window will pop up, which has properties from the here. You can change the name, you can assign material to it, you can change the color, you can change how its transparency means how transparent you want it. Okay, so this much things you can do here. So let's change it to copper, right? If you want to change its color, you can give any color to this. You can even make it very transparent if you want. So if you want like if you are keeping one material above the other and you want to see the below material also, then you can keep the above material somewhat transparent so that you can see through that. This is the like the function of that transparent thing. Okay, understood? Maybe here we will not
Yes.
we don't need it, but in future if you draw such geometry that you want to see the below structure also, then you can make it transparent. Okay,
Yes, ma'am.
so you understand how we have assigned material uh, to our object. You understand this, right?
Yes, yes, ma'am.
Okay, it does not change color. Huh? Let's do it one by one. I think I touched something. Um, Is happening. Okay, sorry. If its color is not showing, then okay. So you have to click OK every time. A mistake, I have not done that. Okay, just click on the binding, select copper here, change color, click here OK, and then apply. If you want to change color, it's on you. Okay, you understand? So please assign copper to this all these windings and keep core as ferrite. Okay, tomorrow I'll ask you this which materials we can use for core and winding. Okay,
Okay, ma'am.
and why also. Okay, so give copper to this winding and give ferrite to the core. Our core is this, right? See, some materials are already available, readily available here. But if you don't want this material, if you want to create your own material, that also you can do from here, like add material or edit material. If you just want to change some property like permeability and all, okay, so that also you can change. This this you can change from datasheet. I think you are third year students, right? Mostly third or fourth year students, right?
Yes, ma'am.
You know, you have you might have seen data sheets of components, right? Or not? Okay. So every component, whatever you are using in example MOSFET and all, they have their own data sheets. Just like that, this
Yes,
material
yes, ma'am.
yeah, these materials also have their own data sheet. When you are buying it from some manufacturer, these materials also have their own data sheet. So if you want to change certain component or if you want to add material, that you can do here. Okay, that we will cover, but not in this class. Okay, we will cover it later,
Okay.
but we will see how we can add material and all. So you don't need to remove. For now, we are just like starting from the basic. That's why we are using that readily available materials. Okay. So here you can see that so much of materials are available here. Mostly, if you just want to do basic simulation, you will get the materials that you want. Okay. But if you want to do for a specific application and you want to use your own material only, then you can just add your own material and you can perform your simulations. Okay, fine,
Okay, ma'am.
understood?
Yes,
Yeah.
ma'am.
Okay. Do this for all the findings. So now from vacuum, it has came under copper, right? So through this, you will understand means which winding is left. Okay. Okay. Uh, I'll suggest you one thing. Before duplicating, please assign your materials to the geometry. Okay. Because I have to do it again. If you will not assign it before duplication, you have to do it again. So it's better to assign it before duplication. Okay.
Okay, ma'am.
Let me just finish this. Then we will. This one I will. Mhm. Okay. So now you have copper and you have ferrite material. This is material for core and this is material for winding. These two things are done now and you know how to change its color and all. I have not done for every winding, you can do later, okay? This is just
Okay, ma'am.
to like differentiate your materials. Like you can assign different color to different materials, so you can just differentiate it. Or if you want to copy paste it in some papers and all, it will look good. That is only the purpose. Okay.
Okay, ma'am.
So let's start with our day 3 objective. So in for day 3, we will learn how to assign boundary, excitation, and mesh setup. Okay. We will first start with boundary. So for assigning boundary, what we will do is we will select the rectangle. Again, enclose this drawing in that rectangle. Make it transfer. Here you will understand the importance of transfer. Make it transparent so that you can see your geometry. Okay. So now you see by making this transparent, you can see your geometry, right? Right. So the question might come is, sir, ma'am, please tell us before that why we need boundary and all, right? You are just telling us how to draw the boundary, but why we need it? So when uh, we are doing simulation on this, right? So this is our what a geometry of interest we can say this, right? But if we just assign boundary here, what will happen if our flux is flowing outside of this region, that will not be visible for us. So we create boundary so that like this by creating this boundary, we are like assigning that this is like our area of simulation. Understand?
Yes, ma'am.
Yeah. So in short, if I'll just tell you, uh, see it can simulate for the whole page also. It can simulate for this much geometry also. If it will simulate for the whole page, it will take a lot of time. If it will simulate for only this geometry, then outside fields or outside any if we want to see fields outside of this geometry, we will not be able to see that. That's why we assign one boundary here so that our calculation time will save, and also outside, if there is some outside field also, that we will able to see. This boundary is on us, means how much we want this rectangle, it is on us. There is there is no rules for it. When rule will come in picture for this, I'll tell you. But for now, just understand there is no rules for it. Okay. So then what we will do is we will change object to edge and select the edge of the outside rectangle. Go to boundary, assign, and assign balloon boundary. Understood how to assign boundary?
Yes, ma'am.
Okay. Yeah. Actually, in boundaries also, there are different things. Like you can see all of this. Actually, we don't need all this. Balloon is like sufficient for us. It's just like we just want to see the outside field and all. So these have their own importance, but we don't need it. Okay.
Yes,
Fine.
ma'am.
So we are done with boundaries. Now we will go to excitations. Okay.
Yes, ma'am.
Okay. Excitation, for excitation, we are assuming that our coil is wound like this is our secondary coil, this is our primary coil, this is our secondary coil, this is our primary coil, and this is our secondary coil. So for shell type transformer, there are different configuration in how you can wound your coil. So I'm assuming that my first layer is secondary, my second layer is primary, my third layer is secondary, my fourth layer is primary, and again my fifth layer is secondary. This is known as interleaved winding. Okay. This also you can read like types of how you can wound the windings for shell type transformer. Okay. Understood? Okay, let
Yeah,
me
ma'am.
show you some. Maybe you will understand it. This is also one way to wound it. Like before we will wound like just HV winding and later we can just wound LV windings. This also we can do. Here we will get, then we have to form like two rectangles, right? For this and this.
Yes, ma'am.
Understood? Yeah. Can you see here? Like the first layer is LV winding and the second, this is not shell type transformer. I'm just giving you an example. The first layer is like LV winding and second layer is HV winding. So LV HV is like primary and secondary winding. Okay. So same we are doing here. The first layer we are assuming as secondary winding. The second layer we are assuming it as primary winding. Like this, we are assigning windings. Understood? Okay.
Yes, ma'am.
Okay. So just select your first winding, assign excitation current. So I'm just giving a value like 12 ampere here for primary winding. Uh, let let's do one thing. Let's select all the primary windings and do it together. So which are my primary windings? This. This, 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 and this. These are my primary windings, right? Then I'll just assign excitation current. So I'm assuming 12 ampere current for now. This is assumptions like whatever you want to put, you can put here, depending on your voltage and all rating. Okay.
Okay,
And
ma'am.
now reference direction I am keeping negative. So this reference direction is with respect to whether your current is flowing in the negative y direction or in the negative or in the positive y direction. Okay. So I'm keeping for primary windings, I'm keeping current negative Why? Because I'll just draw. So, example, this is your primary coil, right? And this is your secondary coil. This is your core, right? So, when in primary coil, you give excitation. So, current flow like this, right? So, its direction through the winding will be in negative y direction. Means it will be downwards, right? That's why we are giving here negative direct for primary coil. We are giving negative direction. Understood this? Why we are giving negative direction? Or it is confusing? Similarly,
No,
for
ma'am.
from secondary, your load is attached. So current flows like this from secondary winding. So through your winding, current flows in upward direction, right? So for secondary, your reference direction will be positive. Understood?
Yes, ma'am.
Good. So then we will assign excitation for your secondary windings. You do one thing, you just name this winding because like I am getting confused, you will also get confused. So just name this winding, okay? Primary, secondary, primary one, secondary one, so that you will not get confused. Okay? Assign excitation current. I'm assuming my secondary is having 8 amperes. Okay? So my secondary is high voltage or low voltage? What is the ratio transformation ratio? What is it? If my primary current is 12 and my secondary current is 8, what is N1 by N2? Turns ratio? Hello? Hello, guys? Oh. Can any one of you answer this? You are in, you have read transformer already, right? It's working the turns ratio and all.
Ma'am, reciprocal of current.
So N1 by N2 will be I2 upon I1, right?
IT upon, yes, ma'am.
Yes. So this is what we are assuming that my primary side is low voltage and my secondary side is high voltage, right? How I have assumed this, you have understood? V1 upon V2 is
Yes, ma'am.
N1 upon N2, right?
Yes, ma'am.
And I2 upon I1 is N1 upon N2, right? So my N1 upon N2 is 8 by N1 upon N2 is ratio, tell me the ratio. 8 by 12, right?
Yes.
And V1 upon V2 is 8 by 12. Which will be my high voltage side and which will be my low voltage side? Okay, you read this. I'll not go into that. For now, we are just assuming that my primary current is 12 ampere and my secondary current is 8 ampere. Okay. We will just stick to this now. Okay. So for primary, I've told you that it will be negative direction. For my secondary, it will be positive direction. That also I've explained, right? Why it will come positive? You guys understood that,
Yes,
right?
ma'am.
Good.
Yes, ma'am.
So here also you can just name it if you want, like secondary windings, so that you will not get confused. So you have 6 seconds. Here also I'll just rename it primary, so that we will not get confused. So now you understand how we are assigning the excitation. You guys understood this? Should we
Yes,
move
ma'am.
forward? So our boundary is done, excitation is done. Then comes parameters. Just right click on it. So its importance I'll tell you later while we will analyze it and see the results. But for now, I'll just tell you how we can assign the parameters. So just right click on this, assign, then matrix, and select all the windings. Okay. Okay. So we are going stepwise. Boundary is done, excitation is done, parameters is done. Now comes mesh. So mesh operation is like do you know what is mesh? So like uh, I've made my 2D structure like this, right? Now what Ansys has to do? Now Ansys has to simulate it. But for simulation, what it does, it it solves the Maxwell equation for this, right? So for everything, it solves the equation and finds the solution. Just like in MATLAB, every components have some equation and MATLAB solves it, and get the result. Similar thing happens here, right? You know this, like in the background, mathematical calculation goes on in every software. You know this, right? Okay. So what ANSYS does is this is my rectangle, right? So ANSYS divides this rectangle into smaller sections, which we call it as mesh, means into smaller elements, so that it is able to solve the Maxwell equations and give us accurate analysis. Like just like example, I'll tell you. I'll just show you. So like example, this is your object. So it forms mesh like this. The green part, are you being able to see? Hmm.
Yes,
So it just what it is doing means this whole the rectangles you are the triangular part you are seeing, this whole mesh thing. So what it is doing is it is dividing this object into
partition,
smaller
ma'am.
yes, into smaller section and forming that object, right? So by solving each section, it is giving you a result. So this is what is meshes. This is what mesh is, right? So we cannot keep a smaller mesh, because if we will keep smaller mesh, your analysis time will increase, because example, you are dividing this rectangle into 100 parts. or you are dividing this rectangle into 1,000 parts. So 1,000 parts will take more time, right? So mesh, you cannot keep smaller mesh. Understood?
Yes, ma'am.
Similarly, if you will keep large mesh, so if you are just dividing this into 50 parts, you will not get accurate results, right? So one thumb rule we follow, that whatever is the length of this, we just keep it, keep it's 1/4. So let me just explain you. There is my core. What is the dimension of my core? 24.
24.
Yeah. So just go to rectangle, right click, this window will appear. Then assign mesh operation, inside selection, length base. Then by default, one value will come. If you are fine with that value, you can keep it also. Or 24 by 4. 24 by 4. 3 mm will come, right? You can keep 4.8 also, what was default, or you can change it to 6 mm. So like it's like it's not compulsory, but it's kind of a thumb rule that keep it like 1/4 or less than 1/4, okay, of your dimension. So
Okay,
we
ma'am.
will let it on 4.8 only. This is for 4. Okay. Now for my windings. Just select all the windings. Assign mesh operation, inside selection, length base. This is 0.3 mm by default. You can change it to 2 mm because you have like your winding is too small, right? You
To
can
get
change it to
accuracy, ma'am.
2 mm. Yeah, you can change it to 2 mm, or you can keep it 3 mm by default also. It's fine. So this is calculating for all the windings. So this 2, 4, how much we have? 10. 10 mm we have, right? If we will calculate it, it is 10 mm, right? Together? No, 5 mm, right?
Yes, ma'am. 5 mm.
5 mm. So we will just reduce it to 2 mm somewhere. Okay? Then, okay. Because this was a bigger cross section. These are smaller cross section. That's why we are keeping small mesh for this and somewhat bigger mesh for this, for accuracy. Understood?
Okay, ma'am. Yes, ma'am.
Okay. Then comes analysis part. Here, you have to right click it and then add solution type. This number of passes, actually you can keep whatever is kept default. This is percent error, is how much error is acceptable. You can increase it to 5. It's fine. Okay. Then here in convergence, you don't need to change anything. This also it's fine. Solver is okay. I first have to change solution type. Okay. Let me, we have some time, right? Okay. Can you guys give me 5 more minutes? Like after 8:30, 5 more minutes will be fine for you, right?
Yes, ma'am.
Yeah.
Yes, ma'am.
So, rest of the part we will do tomorrow. I just have to explain to you the solution types for this. So for adding the solution type, just right click on your Maxwell 2D design, add solution type. So you will get this window. First you have magnetic, then your electric solutions. So we are dealing with transformers, so we will focus on magnetic solutions. I think rarely you will focus on electric solutions. So mostly you will deal with, means you have to see fields and all, right? So mostly you will deal with magnetic solutions only. So here you will see three types of solutions. First is magnetostatic, then eddy current, and third is transient. What magnetostatic does is it works for DC current. So if you are giving DC current, then you will select magnetostatic as your solution type. Okay, but in transformer you don't give DC current, right? You give AC currents, right? So then what you can do,
Yes, ma'am.
you can change your solution type to either eddy current or transient. So what eddy current does is, eddy current is used when your frequency is fixed, like for sinusoidal excitation, you can say. So when you have reached to a steady state and you have now a signal with the fixed frequency, you use eddy current. Okay, understood? Now the last part is transient. So you know that this transient is used when your signal is varying with respect to time, with not with a fixed frequency. Frequency can change there. Understood what I'm trying to say? Eddy current is used for fixed frequency, but in transient, it is not compulsory. It's time varying. Okay. So for now,
Yes, ma'am.
we are selecting eddy current only. Okay. Just click on OK. So you understand which solution type we can use for which thing. If you want to analyze transient behavior, then click on transient thing. If for AC signals, if you want to analyze steady state behavior, click on, transient and steady state thing, right?
Yes, ma'am.
Yeah. So if you want steady state behavior, then you can click on eddy current. And then magnetostatic is used for DC currents. Okay. So we will click on eddy current. Now, I think we can move forward with analysis. Analysis, just add solution type. This we have done. Can increase the percentage error, it's fine, or you can keep it on 1. Here in solver, it will ask you for frequency. Okay. So I'm assuming I'm using high frequency transformer, so I'm keeping it as 150 kilohertz. You can change it to any value. If you are designing for 50 hertz, you can keep that. If you are designing your transformer for means for whatever frequency you are designing your transformer, keep that value in adaptive frequency. Understood? Under solver. Okay. Okay. So whatever, or like, to design your transformer, you first need to know the frequency on which it will operate, right? So that frequency you have to mention here. Okay. And then just click OK. Only this in setup, only this solver, this frequency thing is important. On how much frequency you want to run your transformer on, right? Fixed frequency. So this is just important here. Understood? Now,
Yes, ma'am.
optometrics left and results and field overlays. This we will do tomorrow because I have to discuss a lot of things in results. Therefore, we will do this tomorrow. Okay? Fine.
Okay, ma'am.
So in today's lecture,
Okay,
do
ma'am.
you
That's
guys
fine.
have any doubt in anything?
No, ma'am.
It's fine.
Yes, ma'am.
Okay, then.
Thank you, ma'am.
Yeah, whatever you have not understood, please ask in tomorrow's class. It's fine. I can repeat things. Okay?
Okay, ma'am.
Yeah. Thank you.
Okay,
Then,
ma'am.
okay. You guys can leave. I'll just end the meeting. Thank you, guys.